Approximately 1.4 million years ago, an enormously powerful explosion of unimaginable size occurred in Canada, which was equivalent to the simultaneous detonation of 410 million tons of TNT. The remnants of this massive early Pleistocene blast can now be found in the barren tundra of northeast Canada, where a highly obvious circular lake stands out like a sore thumb. This Pingualuit Crater feature represents the blast site, marking the Pingualuit Impact Crater, which for all intents and purposes represents the most pristine of the 34 confirmed and highly probably impact craters found across the entirety of Canada. Measuring 3.44 kilometers or 2.14 miles wide, this impact structure is vastly larger than Arizona's Meteor Crater, and more than twice as deep. Not only is the water within this lake absurdly pure, with some claiming it to be the world's freshest lake, but it also surprisingly contains a species of native fish within it. And this is despite the fact that it is disconnected from any other rivers or bodies of water home to Arctic char. Thus, the fish likely found their way into the crater tens of thousands if not hundreds of thousands of years ago, when the crater was not disconnected from other bodies of water, with their descendants remaining there ever since. For reference, Pingualuit Crater is located as the far northern section of Quebec, where it is 47 kilometers south-southwest of the Katanique-Donaldson Airport. While we've never found meteorite remains from the asteroid which formed this simple impact crater, the fact that underlying rocks which experienced significant melting during the impact became enriched in both iron and other metals suggests that the impactor was a type H chondrite. This chondrite originated as chondrites, a 4.5 billion-year-old main belt asteroid that was not particularly dense. In the early solar system, particles of rock the size of sand and cobbles merged together due to the force of gravity, forming small asteroids. Although many of these asteroids went on to become larger bodies of rock such as planets and larger asteroids, others remained. Chondrites, when viewed up close, contain numerous small spheres of material clumped together. More than 85% of all meteorites which enter the Earth's atmosphere are chondrites, with 33% of the overall total being H chondrites. The impacting asteroid likely measured 201 meters or 659 feet wide, and 1.4 million years ago was hurling towards our planet's upper atmosphere at a speed of 17 kilometers per second or 38,000 miles per hour. Continuing onwards, it began to break up at an altitude of 50 kilometers. Impact effects: only a few seconds later, large fragments of this asteroid struck the ground in a 350-meter radius, releasing an immense amount of energy equivalent to the detonation of 410